Starting the notes. We can look at it later. All right, so today we are going to work on contingency tables, which should feel kind of like review. It gives us some of the same information as a Venn diagram. Okay, so these are tables that display the frequency from two variables. We really could have more than two variables, actually, that have multiple categories. The individual cells in the table show the intersection of the two categories. So we have our Venn diagram here from yesterday's lesson, which involves students taking Spanish class and also marching band. So we're just going to fill in this little dealio. So how many were taking Spanish and in marching band? 12. So we put a 12 in here. Don't put it in the middle because we're going to label it in a second. Okay, what about how many are taking Spanish but are not in marching band? 13. How many total taking Spanish? 25. Good. Okay, then we're looking at not taking Spanish. So how many are not taking Spanish but are in marching band? 11. Okay, how many are not in marching band or Spanish? 4. For a total of 15. Okay, so in marching band, what am I getting? 23. In not marching band is 17. Does that look right? For a total of 40 students. So we know that we've done this correctly if the 25 plus 15 equals 40, and also 23 plus 17 is 40. Check, check. Okay. So we did all of this yesterday, but we just did it with the Venn diagram. Do you see how it's telling us some of the same information? Okay, awesome. So how many students are in the marching band and not taking Spanish? So in the marching band but not taking Spanish, that's 11 kids. How many students are not in the marching band? Guys, we just answered all of these questions. Do we need to answer these again? This is ridiculous. 17. 17. Thank you. All right, what is the probability that okay, now we're getting to the good stuff. What is the probability that a randomly selected student from the survey is not in the marching band? Okay, how many kids are we picking out of? 40. We're picking out of all 40 because it just says from the random from all the kids in the survey. So, what is the probability of not in the marching band? Not in marching band. Please make sure you are practicing this notation with me because you will lose points for not having it on your assessments. Oops, that's marching band, guys, not just marching. Okay, so how many total are not in marching band? 17. 17 out of 40. Does everybody understand where those numbers came from? Okay, now we just give the probability with 3 decimal places. That's a decimal. So I'm doing 17 divided by 40. I should have 0.425. I'm going to use an equal sign because that was an exact answer. I didn't have to round it. 0.425. What did you say, hon?
Wouldn't it be like, can I just put 0.43? Like, can I round that?
No, we're doing 3 decimal places.
Oh, okay.
Okay. Okay, what is the probability that a randomly selected student is taken in Spanish given that they are in the marching band? Now, what is the key word here?
Given.
Given. Oh, you guys are going to do great at this. Okay, so this changes a little bit. It's probability of Spanish given marching band. Okay, so Now we're not picking out of everybody. We're only picking out of the marching band kids. How many total kids are in marching band?
11. Well, you mean Spanish and Martin?
No. We're given that they're in marching band. So we're not picking out of all 40. We're only picking out of the marching band kids. How many total kids are in marching band? 23.
Could be 12 or 23.
Okay, and then there are 12 of those 23 that are taking Spanish. Does that make sense to everybody?
Yes.
Okay, so this marching band changes the denominator. The given marching band changes our sample space. Now we have fewer outcomes to pick from. All right, so let's put that in the calculator. 12 divided by 23, 0.522. So approximately 0.522. Okay, next. I can no longer see my numbers, so I'm going to have to rely on you guys. Actually, I've got this printed out. What is the probability that a randomly selected student is in the marching band given that they take Spanish? Okay, do you see that the given is flip-flopped now? Mm-hmm. So now I want the probability of marching band given that they're in Spanish. Okay, so instead of picking out of the 23 marching band kids, we're picking out of the kids taking Spanish, of which there are how many?
25.
25. Okay, isn't it still the same 12 students that are in both?
Yes.
Yeah. So the numerator is staying the same. It's just we're picking out of a different set of kids. So this should be a slightly smaller probability. 12 divided by 25. I got 0.48. Exactly. So you just have to be careful about which one is the given condition, because the given condition is the one that selects the denominator, the sample space. Can you please put that phone away so that I don't have to put it in jail? Thank you very much for your cooperation. All right, what are some advantages and disadvantages of Venn diagrams and contingency tables? Do you remember how much work we had to do adding and subtracting for the Venn diagrams to like find the number? Do you know what I mean? Like, not that it wasn't possible, but like also wasn't it kind of a lot of work? The frequency table, to me, it's nice because it has the totals, right? Okay. Guys, this is your, like, I think I know what they are, but I need you to be writing in your own words. What advantages can you think of? Can you stop? Yeah.
I'm not even talking.
So, the frequency tables have those really helpful totals, so we don't have to do all that annoying adding and subtracting on the fly, right? They're just given to us. The Venn diagrams do what?
They give us the totals categories.
Okay, well, that's like a disadvantage. So what is an advantage of a Venn diagram? It shows you, like, isn't it kind of visually easy to see what's going on and where the overlap is? You know what I mean? So, like, there are strong visual cues for the Venn diagram to help you see what is going on in, like, the overlapping categories. Okay. Guys, In our notes yesterday, we talked about joint probabilities. So remember that joint probabilities is intersecting conditions. It's the and. So things that are joined with the conjunction and. So which of these are joint frequency? Yeah.
12 and 4.
12 and 4 are joint. So this one is a joint. Which other one?
4.
4 is joint. Which other ones? Which one? No. Nope.
So are the other ones considered marginal?
So this is joint and this is joint. Okay, so the 13 is the intersection of Spanish and not in marching band, right? The 11 is the intersection of in the marching band but not taking Spanish. Does that make sense to everybody? Those are the intersection of those. Okay, the other ones, like you said, are marginal frequencies. These are marginal. Where are the margins of your paper? Off to the side and up at the top and the bottom, right? Those are your margins. Aren't these off to the margins? Okay. The joint ones happen in the middle. Okay, did you label your table?
Yeah.
Okay, good. All right, let's go to the next page. Okay, using our data from lesson 1 point. Ooh, just kidding. Is that what I printed out for you guys?
Yeah.
Oh, that super duper sucks. Okay. I fixed it in the Word document and then forgot to change the PDF. Okay, give me a second. Okay, so I'm sorry that this sucks right now, but we are just going to copy down what I've got.
That is amazing, actually. Yes. Brainstorm.
Okay, make this kind of big, guys.
I'll give you
Oops. All right, guys, you're going to need 1, 2, 3, 4, 5, 6 columns. Okay, can we have the tapping stop, please? Thank you. And then you're going to need 5 rows. Okay. All right, so we have, okay, more than one pet. One pet. No pets. And a total.
what's the top of it?
I'm about to tell you. All right, flying. Invisibility. Oh my goodness. Super strength? Oops.
Speed.
Okay. It's just going to be that. Telepathy, I guess it's called. And then our total. Okay, so what I'm going to do is give you some numbers, and then you're going to figure out what the rest of the thing is by what's missing. Oh, there's only one with super strength. It deleted mine and then rewrote it on there. Sorry. There's only one with super strength, guys. Okay, you should be able to fill in all the ones I left blank. Okay, so if I have 12 total that have more than one pet, how many of those want to be invisible?
4.
Correct. Okay, how many total people have one pet?
3.
3. That is correct. Okay, how many of the no pets people want to be invisible? Is it 2? No? Wait,
Go to the bed.
1. Yep. Okay, how many of the no pets people want telepathy?
3.
Correct. All right, how many total people want flying? 4. What about super strength? 1. Yes.
There you go.
Yes, I said yes.
Oh, shoot, I do.
All right, so let's suppose that the function f maps a category to its frequency. What would be the value of f has no pets? So f of no pets is what? What is the frequency for no pets? Correct. 4. 4 people. Everybody understand where we got that?
Yes.
Okay. So this function tells us the number of people that meet that requirement of having no pets. All right, how do we know? Okay, because 4 total people have no pets. Okay, what about the value of F? Wants a superpower of flying. Can we just call that F of flying?
Yes.
F of flying. What is F of flying? 4. Because when we add up all of the flying cells, we get 4. Okay. This is where it's going to get more exciting. Because we've got some intersections. What would be the value of f of one pet intersecting with wants telepathy? So we're looking for one pet and wants telepathy. One pet wants telepathy. Yeah. One, because the cell for the intersection of those categories has a 1 in it. Is everybody okay with cell being the box? Okay. Now we're going to do a union. What would be the value of f of more than one pet with the union invisibility? Okay, now this one's the tricky one. This one is the one where we could count some people twice. So how many total people want more than one pet? Or have more than one pet? 12. Okay, and then we're going to add those with the ones that want invisibility, which is 7. Okay, but then there are some folks that we've counted twice. There are how many people that have more than one pet and they also want invisibility?
7.
No. 4. Okay, so we have to subtract away those doubles that overlap. So it's minus the 4. Does that make sense to everybody? Okay. So that is that 15?
Yeah.
So the important thing to like, how do we know? Because we counted that one cell twice, so we had to subtract them away. Hey, can you put away your phone? All right, number 14. What would be the value of f has no pets intersected with no flying? Oh, this one's exciting too. No pets intersected with no flying. So the people that didn't pick flying. Okay, so how many people had no pets? 4. Okay, how many of people did not pick flying?
15.
Right. Wait a minute. I'm just having a brain fart. We're not doing union. Okay, let's look at the diagram. Sorry. Okay, so we want no pets intersecting with no flying. So let's just pick out which cells that is. So no pets, I'm going to highlight. because my brain just gave up a little bit. Whoops, I thought that was bigger. Hold on. Okay, so we're looking at no pets, and then they didn't pick flying. So that's all of these people. Okay, so the intersection of those criteria is, whoops, I guess I can make them red. This right here. Does everybody see where that intersection is? Okay. So that's 1 plus 0 plus 3 if you can't read it. Whoops. 1 plus 0 plus 3. It's 4. Another way to think about it, guys, is it's all of the no pets people minus the no pets people that picked flying, which none of them did. So it's basically all of them. Sound good? Okay. This just keeps going and going and going. Are we having fun yet? All right, we're over halfway done.
So the answer would be more than?
It's 4. Okay, what about the value of F of has more than one pet, union does not want super strength? More than one pet does not want super strength. Okay, let me get rid of all this stuff. So this time we're after more than one pet. And does not want super strength. So how many in that one? Oh shoot, I just did intersection, didn't I? Oh my god. All right. Thank you. Okay. Now we're doing union. So we're going to add the two categories together and then subtract the overlap. So how many of our people have more than one pet? 12. Ew. Okay, how many people do not want super strength? 18. Okay, and then we have to subtract the intersection of those categories. So all the ones that we just highlighted, this one, and this one, that's what we have to subtract. Are you guys okay with that? Okay. So I don't feel totally bad because we didn't totally waste our time highlighting because those are the ones we get to take away. All right, so I'm getting 19. Okay, so the answer for number 15 is 19. Okay. Relative frequency. This is the ratio of a frequency to the total number of data points. So in the small upper little corner, we're going to write, like we had 4 people here. How many total people were there? How many total people? No. In the whole survey. 19. So this is out of 19. That's what we're going to do. Okay, for invisibility, we had 4 out of 19. We had 1 out of 19, 3 out of 19, 12 out of 19, 0 out of 19, 2 out of 19, 0 out of 19, 1 out of 19, 3 out of 19, 0 out of 19, 1 out of 19. Oh my God. Guys, I swear I made a version of this where this was all done for you, and I don't know what happened to it. I think Coach Vogler ate it. Either that or the internet ate it. But hopefully we just learn it that much better for having to do it. Okay, so we're not even done after this because now we have to convert them into decimals. You guys are going to love this. Okay, so now we have to turn all of these into decimals. Okay, give me 3 decimal places for each. Once we get 4 out of 19, we can put that everywhere we see 4 out of 19. So we don't have to do them like a million times. 4 divided by 19 is 0.211.
It looks like the same box.
Yes, that's why we did it off to the side. Okay, here's one. Did I get them all? All right, 1 out of 19. I got 0.053. Anyone that says 0, you can just say 0. That one's kind of fun. For 2 out of 19, that'll be 0.105. For the 3 out of 19, that will be 0.158. The next one, I guess, is 7. 7 divided by 19 is 0.368. And then 19 out of 19 is obviously 1. Whoop, I forgot 12. 0.632. All right, everybody still alive? Okay, so these are going to add up to the total of 1, just like the other ones added up to the total of 19. You guys see that? If I add up the 0.632, the 0.158, and the 0.211, I should get 1, right? They're all going to add up to the totals and everything. It just tells us that, let's say that we doubled our sample size, we would expect that these frequencies would still kind of hold true. Does that make sense? It doesn't just tell us out of like the 19 people, it tells us like out of A sample. Okay, never mind. Okay, a function that associates a probability with each possible value or interval of values for a random variable is a probability distribution. So the sum of our probabilities for all possible values of the independent variabilities is 1. So remember when we treated distributions like functions? We can make a function for this distribution. Okay, the output is going to be these relative frequencies. So, like, let's say, what would the probability of, out of everybody, what is the probability of picking someone who has more than one pet and wants to be invisible? Yeah, so basically just does the probability for us. It does 4 divided by 19 and it gives us the probability. It computes it for us in the table. Does that make sense to everybody? Okay, awesome. All right, what is the probability that a randomly selected student has no pets? So how many total people have, how many total out of 1 have no pets? You see it's this one right here? So we're going to say the probability of no pets whoops, I'm writing out the word probability and I just need to pee. No pets is 0.211. What about the probability that a randomly selected student wants a superpower of flying? So probability of flying. Yes. Okay, what about the probability that a randomly selected student has 1 pet and wants telepathy? Okay, it doesn't say given, but do you see that there's a given hidden there? Okay. Wait a minute. It's and. It's not and, it's not given. You guys, I'm sorry, it's not given, it's and. So if it says and, what is it? Intersection or union? Intersection. Okay, so we want the probability of 1 pet with the intersection of telepathy. All right, 1 pet. Telepathy. I'm getting 0.053.
Mm-hmm.
Okay, last one. More than 1 pet with the union with invisibility. All right, so how many total people want more than one or have more than 1 pet? 0. What?
632.
Thank you. Probability of more than 1 pet, union, invisibility. Okay, how many total people, or what is the total probability of wanting invisibility?
0.368.
0.368. Okay, what do we still have to subtract away? The intersection. So how many, what is the probability of picking more than 1 pet and invisibility? 0.211. So whenever we're doing union, we're adding the categories and subtracting any overlap that they have. Does that make sense? Yes. Yes. I think we're almost done. Okay, what do we get?
.789.
0.789. Haha, why is 6 afraid of 7?
789.
Hilarious.
It's a real crack nut right there.
The worst joke.
A real crack nut.
Okay, what is the probability that a randomly selected student has no pets given that they want to fly? So, probability of no pets given that they want to fly. Okay, so the given that they want to fly goes in the denominator. So, given that they want to fly is what? Flying is 0.211.
Yeah.
So that's what goes, whoops, sorry. That's what goes in the bottom, 0.211. What about no pets? Wait, what? 0.
That'd be .211.
What is 0 divided by any number?
0.
Yeah. Okay, what is the probability that a randomly selected student wants super strength given that they have more than one pet? So, probability of super strength given more than one pet. Geez, it's so much writing. I'm sorry, guys. It's like the worst categories ever. Okay, so the more than one pet goes in the denominator. More than one pet is 0.632. Okay, how many of those want super strength? What is the probability of picking super strength out of those? So it would be 0.053. Did I do that right? I'm getting 0.84. Sorry, 0.084 is what I meant to say. All right. Brains exploding?
Yes.
Okay.